So dear student, welcome to the lecture series of material science, nanotechnology and material science. So today I will briefly explain one of the very important topic, which is basically a start of a nanotechnology. It is a top to down approach for the synthesis of nanomaterial, and it is known as ball milling or mechanical milling method for nanomaterial synthesis. Dear student, please mark my word. As Richard Feynman said about the nanotechnology, that there is a plenty of room at the bottom. So this means that the material which reached to its nanometric size, or which reads its dimensions into a nanometer, there is a possibility of change in physical and as well as chemical properties. The change in physical and chemical properties of materials are due to the dominance of quantum mechanical effect than a classical effect. So this means that at very small scale, below the nanometer, which is a size which is not visible with the naked eyes, there is a possibility of quantum mechanical dominance, which result into a change in physical and as well as chemical properties. So this was the statement of a founder of the nanotechnology. Now the question here is this, that what could be the possible techniques through which we can prepare a material in a nanometer size. As I have also discussed previously, that there are two different ways. One way is known as top to down approach to synthesize a nanomaterial, whereas there is another way which is known as bottom up method to synthesize a nanomaterial. So initially the first foundation of the synthesis of nanomaterial was laid by a method which is a top to down method, and it is known as ball milling or mechanical milling method for the synthesis of nanomaterials. Dear student, what do you think what the term ball milling means? The student, in the ball milling use a ball mill, which is a type of a classical grinder. So basically the ball mill crush a material which is in the form of bulk. Okay, so the ball mill crush a material and crush it up to a very small scale, up to a nanometric scale, and after crushing them, when the material reaches its nanometric scale, then this material is used for potential applications, especially in microelectronic industry, paint industry, ceramic industry, and many more, like selective laser sensing industries, etc. So the student, in a simple word, ball mill method is a mechanical crushing or mechanical milling method based on top to down approach, and with this method we basically convert a bulk material into a very small nanometer scale dimension material. Okay, so dear student, if I explain or if I define the ball milling or mechanical milling method in a simple word, the mechanical milling method or ball milling method is known as solid state synthesis method. So basically a mechanical milling or ball milling is a solvent free process used in industry to synthesize nanomaterial and is also called mechanical alloying or heterogen method. Okay, so this method is based on a top to down approach in which a bulk material is grinded, reduced into a very fine size of few nanometer mechanically. So, dear student, what do you think why ball milling method is known as solid state synthesis method? The reason is quite simple. The ball material which is used in ball milling method is in a form of a solid bulk material. So in ball milling method, the solid bulk material is crushed in a size of few nanometers. Please note that the ball milling method is usually a solvent-free method. No chemical solvent like alcohol, like toluene, like water, etc. are used in ball milling method. So this method basically crush a solid material and just convert it in mechanically into a very small fine nano powder. So in a simple word, ball milling method is a top to down approach, and it is a very simple method of crushing a bulk material into a very small fine nanoparticle without using any type of chemical solvent. Okay, please note that this method is also known as mechanical alloying or heterogen method. So student, what do you think what the term top to down approach mean in nanotechnology? It can be simply explained by a schematic diagram that in a top to down approach we use a bulk material. Okay, this is a material which is visible with a naked eyes, and this bulk material is converted into a small uh, particulates which are also visible, and these are the fragments and part of the bulk material. And after crushing this the fragment, or after converting the fragment into the fragment which are the remaining of the bulk material, they are converted into a very fine structures, and these fine structures are usually in the range of 1 to 100 nanometers. So at the in top to bottom approach, we convert a bulk material into a fragment and then into a nano structure. So this is the theory behind the mechanical milling and or a ball milling method. So in ball milling, the bulk material in the form of powder in a solid state is incorporated, and it is converted into a fragment and then into a very fine powder in the size of 1 to 100 nanometer. So now let's discuss the important or key part of the ball milling machine. Please note that, as I have previously discussed, that the ball mill is a kind of grinder. Okay, so basically it's used to grind and blend a bulk of material. Basically, the ball milling machine grind and blend a bulk of the material and convert it into a quantum dot or a nanoparticle. As I have previously discussed, quantum dots are very fine nanoparticle whose size vary in the range from 1 to 10 nanometer, whereas the nanoparticles are basically they are diverse and their size are in the range of 1 to 100 nanometers. And the working principle of the ball milling or mechanical milling machine is quite simple. Okay, it is based on impact and adhesion. Impact is basically an application of a pressure or force, whereas adhesion is a crushing and decrease of a material size or bulk material size into a nanometer. So please note that the basic working principle of ball milling is based on impact and adhesion of the bulk material. So let's discuss about what are the essential components used in ball milling machine for the conversion of a bulk material into a nano material. Dear student, please note that usually a ball milling machine consists of a rotating hollow mill or a drum. Okay, so it's basically consists of a rotating drum, which so the student the hollow drum is used in a ball mill, and in this hollow drum the bulk material, which is usually in a form of a powder, is incorporated inside this hollow drum in a ball mill machine. Please note that usually in ball mill instrument, this hollow drum is usually rotated horizontally along its axis. Okay, and with the horizontal rotation and incorporation of the bulk material, the material is crushed. Okay, so the other part of the ball mill machine is known as a hard grinding balls. Okay, these hard grinding balls are very important in order to mechanically crush the bulk material. Most commonly used hard grinding balls are based on steel. There are some hard crushing ball based on stainless steel, ceramics and rubbers. Please, dear student, note that the balls which are used as a crushing material to crush a bulk material are not limited to these balls. There are also different kinds of ball like flint pebbles. They are also used to crush a bulk material into a fine nanoparticle. Okay, so basically, in a principle, in a ball milling machine, the hard grinding balls are responsible in accordance to the rotation of this empty drum to convert a bulk material into a nano material. Please note that the students in the mechanical milling instrument or ball milling instrument, there are used like different kind of balls. The size of the balls varies from large to medium size. Okay, and these large to medium size mills are mechanically rotated on their axis. Okay, but what do you think if the ball mill instrument consists of a small balls? Okay, the small balls normally consist of a cylindrical caped containers. Okay, so their rotation is slightly different than the large balls or medium balls used in mechanical millings. Okay, so the small balls consist of a cylindrical caped container that sit on two drive shafts. Okay, these drive shafts are usually pulley and belt are used to transmit the rotatory motion. Okay, so basically they are uh, the small ball milled setups are based on pulley and belt, which basically transmit the rotation of those grinding balls in the ball milling operators. However, in a case of large to ball large to medium balls used in ball mill operators, they basically rotate, they move basically freely inside the ball mill hollow drum, and it's convert and crush the bulk material into a nanoparticle freely. But in a case of small grinding ball, the small grinding balls are kept with a pulley and belt setup. So basically they cause the rotation of the balls, and with that basically they are responsible to crush the bulk material, and they convert a bulk material into a nano material. This student, please note that another important part of the ball mill is the internal hollow part. Okay, so please note that this internal hollow part of the ball mill play a very important role. Why this internal part of the ball mill operators play a very important role? Please note that since we are basically crushing a bulk material inside the ball mill apparatus, with the crushing, we basically convert the material into a very fine nanoparticle, but the internal hollow part, which is this part, has a different material structure. It consists of a different material, and this material may cause an impurity into a crushed bulk material into a nanoparticle. So in order to avoid the crushing, in order to avoid the impurity, and also the so the student, the internal part of the ball mill is lined or is basically covered with abrasive resistive material. As you know that in ball milling instrument there are hard or soft or different types of ball used inside the hollow cylindrical region. So these balls may collide with the surface of the hollow part of the ball mill, which may create an impurity inside the hollow part in which the nanopowder is crushed. So they basically may cause the impurity in the hollow part in the nanopowder. So in order to avoid the impurity, the hollow part of the ball mill instrument is resistively coated with manganese steel. So there are also different types of coating materials which are used in the ball mill apparatus. But however, most commonly used resistive coating is based on manganese steel. Dear student, please note that it is very important to consider the physical parameters or key parameters which are required in ball milling process for synthesis of the nanomaterials. Please note that these are very important, and usually in research student must consider the physical parameters associated with ball milling to prepare a very fine and very precise and uniform nanoparticles. Dear student, please note that ball milling apparatus is usually based on three main physical parameters. One of the first physical parameter which is associated with ball milling process is ball to powder weight ratio, okay, which is also known as BPR. So ball to powder ratio is milling ball to powder ratio is considered very important if you want to prepare a very fine in very small nanoparticles. Okay, the second physical parameter is, which is considered in ball milling is a time of the milling process. So if you mill a material which is basically a bulk material which is present in the form of powder for a long time, so there is a possibility of getting very fine, very small nanoparticle or nanomaterials. But there are also other issues associated with milling time, that like there is a possibility of impurity in the milled nanomaterial or in the milled nanoparticle. The third physical parameter is usually considered in ball milling process is known as rotational speed. Rotational speed in ball milling process is in RPM, revolution per minute. Okay, so it is also very important. Higher is the rate, there is a possibility of getting more fine particle, but there is also a possibility of incorporation of impurities inside the milled powder or inside the or in the nano prepared nanoparticles. So these are the key three main physical parameters which are considered in ball milling process. So there are also other associated physical parameters in ball milling process. So I will briefly explain one by one all the associated physical and as well as chemical parameter which we need to think before using the ball mill apparatus, and before we want in order to get a highly desirable nanoparticles. Okay, so I will briefly explain this one by one. So the student, the first and the key physical parameter used and considered in a ball milling process is a temperature. Okay, so the student, please note that the temperature will be considered inside the ball milling drum or ball milling apparatus. Number two, temperature of the precursor material or the temperature of the bulk material is also considered in a ball milling apparatus. Okay, we also need to consider that what kind of material, what kind of bulk material we are used, whether this bulk material is previously sintered or annealed, or do we need to anneal the bulk material after doing a ball milling, after getting a ball milled material. So temperature is considered first inside the ball milling apparatus. Number two, before the milling of the bulk material, and after milling, or after getting the milled nanoparticle, and after the temperature after the milled nanoparticle. So these three temperature are considered in these three senses. The please note that, dear student, since in ball milling process the material, the bulk material which you want to crush and convert into a nanoparticle is rotated inside the ball mill. Okay, so there is a certain frequency with which the material is ball milled, and this frequency usually create a temperature. So we also need to consider the frequency of the um, bulk material inside the ball mill apparatus. Okay, please note that if the frequency inside the ball mill apparatus is high, so there will be a more collision of the balls with the bulk material, which will result into a higher temperature inside the ball mill operator. Please note that this temperature inside the ball mill has pros and cons. It has advantages and also disadvantages. In some cases, there is a possibility of an agglomeration or accumulation of nanoparticles with each other, and they may cause nucleation, and the size of the nanoparticle due to a temperature may increase. Okay, so you have to consider the temperature and the frequency inside the ball mill chamber or ball mill drum. Okay, since you know that ball milling is a kind of grinding method, okay, that's grind materials into a bulk material into a very fine nanoparticles, and during the milling process there is usually take place a collision between the milling balls and the bulk material. Okay, so when the milling ball and bulk material collide, there is usually there is also a frequency with which the milling balls and the bulk material collides, so there will be increase in temperature. Okay, so students, keep this in mind that the temperature of the ball milling inside the chamber will depend on the frequency with which the balls and the bulk material which you want to crush is moving. Okay, so the frequency of the collision of the balls and the precursor or the bulk material are very important in order to consider temperature. And if the temperature of the chamber or temperature inside the ball milling chamber is high, this will result into agglomerate, and this will cause an increase in a particle size. So temperature is very important physical parameter. So in a conclusion, the milling temperature or the temperature inside the ball mill drum is very important in getting a final fine nanoparticle. So the end product or the nanostructure which we obtained after milling the bulk material will depend on their structure will depend on the temperature inside the ball milling chamber. And student, please also note that the milling temperature will serious affect if we are using a bulk material which is in a form of a composite or which is in a form of a ceramic. Okay, so basically they are very hard, and due to hardness of this material there is a possibility of structural defects and damage due to a temperature, and they can basically the temperature may create a lot of structural issues in such particle. However, in metals the temperature may be used in ball milling operators in a positive sense, because the metals are usually they can be extracted, they are not too much brittle. Okay, so basically they are flexible to the temperature, and basically we can with the temp inside the ball milling up the temperature inside the ball milling apparatus may effectively improve the quality of the final nanoparticles in case of metals. Another key physical parameter associated with the ball milling process is the size and the number of the balls. Okay, so the size and the number of the balls in ball milling process play a vital role in order to get a very fine nanoparticle or nanomaterials. Okay. So different, usually two different type or two different sizes of balls are used, and these types of balls are number one types of balls used in ball milling process are balls with a larger sizes. Okay, and whereas the second type of balls used in ball milling process are the smaller balls. There are also used medium sized balls in ball milling process. Dear student, please note that if the size of the bulk material which we want to convert into nanoparticle is large, then the balls of larger size are used in ball milling to crush the larger bulk material. However, in case if the bulk material is in the form of a fine particle, then the ball milling we use smaller balls in order to convert the powder into a very fine nanoparticles. Okay. So dear student, the larger balls in ball milling process are used in breaking of the bulk material. Okay, whereas the smaller ball used in ball milling process is for converting a fine powder into a very small nanoparticles or nanomaterials. Dear student, please note that if we are using a smaller balls in ball milling machine, then the power consumption usually in ball mill machine which use a smaller ball is less, and whereas please note that the mill production in a smaller ball is higher. Okay, please note that in order to use a balls with a larger size, there will be a larger amount of power consumption. So larger balls in ball milling process, they use too much power. And secondly, the product or the bulk material which we want to convert into a nanoparticle are basically they wear at if we use a ball with a larger size, they usually wear inside the ball mill operators. So both the smaller balls and as well as the larger ball in ball mill machine or in ball mill process has pros and cons. Okay. Similarly, dear student, the number of ball in ball milling process are also important. If let's say we are using less amount of ball in the ball milling drum or in the ball milling machine, they will take too much time to crush the bulk material into a nanoparticle. So dear student, please note that the grinding time will increase if we use a lesser number of balls in ball milling operators. However, converse is a case for if we use a higher number of ball inside the ball milling apparatus. Like if we have more, or if the number of the ball are more in ball milling apparatus, the consumption of the time will be less and we will get fine nanoparticle in lesser time. Okay. So dear student, please note that if the balls are loaded too much in a ball milling apparatus, they during a process may overlap with each other. Okay, so let's say if this ball drum has too many balls inside it, then there is a possibility that during the crushing of the bulk material these balls overlap with each other, and due to an overlapping of this ball there is a possibility of a decrease in efficiency of the milling of the bulk material, number one, and number two, there is a possibility of an incorporation of the impurity due to the overlapping of the ball present inside the milling apparatus. Okay, so dear student, please note that the number of balls used in ball milling process also play a vital role. So usually, dear student, the volume percent of the ball will depend on the size of the chamber, okay, of the ball mill apparatus. Usually in new ball milling apparatus, usually 30% of the mill volume of the mill drum is used for milling balls, okay, and this may be increased over the period of time in order to increase the efficiency of the milling bulk material. Okay, so it will depend also, like the efficiency will depend on the nature of the ball milling drum. Usually the volume of the ball used in ball milling apparatus are somewhere around 30 to 50%. However, mostly the volume of the ball used in ball milling apparatus are in the range between 30 to 40%. Okay. So in a simple word, dear student, the size of the ball and the number of the balls used in ball milling process play a very important role in order to get a desired nanoparticle. Please note that the sizes of the ball used in ball milling process are in the range between 20 millimeter to 150 millimeter, whereas number of balls used in ball milling process are usually around 30 to 50% of the ball milling. Okay, so the size and the number of the ball in the ball milling process play a very important role in order to get very fine well-oriented desired nanoparticle. Another key physical parameter used in ball milling apparatus is the nature of the ball. Okay, so different types of the balls are used in ball milling apparatus. These types may include the balls with steel, the ball based on ceramics, and also ball based on rubber materials. Okay, and in case if we want to crush a harder material, there usually the tungsten balls or even hard metal balls are used to crush the very hard metals, okay, or very hard material. This trend, please note that the balls used in ball milling process will depend on the nature of the bulk material which we want to crush. The strength, please note that usually, as I have previously discussed, that the ball mill instrument consists of a hollow cylinder which is known as a drum. Okay, so the bulk material in a form of powder is incorporated inside this bulk. Okay, inside this drum. So when the bulk material is incorporated inside the drum of the ball mill, we need to crush it. So it is not easy if we have a hard material and we want to crush it with rubber balls. Okay, So the ball used in ball mill operators will depend on the initial precursor material which we want to crush. Okay, if you want to crush a harder material, usually the tungsten ball are used to crush the harder materials. So most commonly used material in as a ball in ball milling operators, as I have discussed, are steel, tungsten, carbide, zirconia, alumina, and also silicon nitride. So these are the key type of material used as a ball to prepare or to crush the bulk material. And there is also, in case if you want a material based on a soft materials like polymers or soft polymer, there are also a kind of rubber balls used in ball milling apparatus to crush them and convert them into a nanoparticle. Okay, another key parameter considered in a ball milling apparatus is ball to powder ratio. Okay, so this is very important key parameter in ball milling process. Ball to powder ratio is very important in context of getting a very fine particle, nanoparticles, or in order to get a nanoparticle with a higher capacity and and a device to operate with a better efficiency. So the student, ball to weight ratio, if the number of ball are more than the number of powder, then there is a possibility of overlapping of the balls, and which may cause the impurity in the powder. Similarly, if the amount of the powder of the bulk is too much to the ratio of the balls, then there is a possibility of decrease in efficiency of the milling. So lesser amount of the powder will be converted into a crushed nanoparticle. Or there is also a possibility of increase in time and also a power consumption. So the time also prolong if we use less balls and more powder. Okay, however, converse is a case if we use more ball and less bulk material, then the efficiency, then the time of crushing of the bulk material into nanoparticle will be very short. Okay, so this one, please note that different types of ratios are used in ball milling apparatus, okay, or ball milling process. Usually the advisable ratio of BPR or ball to powder is around 10 to 1. However, in some cases the ball to powder ratio, such as for ductile charge gases, the ball to powder ratio is around 15 to 1. So the student depend on the situation that usually, please note that the ball to powder ratio will also will depend on the size of the powder, like what is the diameter and what is the range of size of the powder. And secondly, it will also depend on the diameter of the balls. Okay, so this may vary with the size of the balls also. Usually the advisable range of ball to powder ratio is around 10 ratio 1. In many situations this ratio is used. However, for effective ball milling, you can even go up to 20 to 1 ratio. Okay, and in case of ductile charging, the ball to powder ratio is somewhere around 15 to 1. So ball to powder ratio varies from 10 ratio 1 to 15 or and even 20 ratio once. It depends on the size of the ball, nature and the size of the powder, and also the requirement of the end product. So the student, another key physical parameter which we need to consider in a ball milling processing is the rotational speed of the ball milling drum. Okay, this rotational speed of the ball milling drum play very important role in crushing of the bulk material. Okay, dear student, the rotational speed in ball milling apparatus varies between 20 revolutions per minute, between 4 to 20 revolutions per minute. Okay, so please note that the rotational speed will depend on the nature of the ball, size of the balls, and also the material which we want to crush. Okay, so all these three parameters are usually considered before using the specific rotational speed in ball milling apparatus. Okay, so usually the rotation speed in ball milling process is around 4 to 20 revolutions per minute. Student, I have not mentioned the mathematical formula for the critical speed required in ball milling apparatus, but usually, just for information, please note that the critical speed of the ball mill apparatus is usually equal to 76.63 divided by under root the diameters of the balls. Okay, so dear student, please note that the ball mill apparatus will depend on the diameter of the ball, and also also on the size of the inside part or the hollow region of the ball mill apparatus, and also on the size of the bulk material which you want to crush. Okay, this student, please note that the rotation of the drum in opposite direction to the revolution is more effective in order to get a very grind uh, nanoparticle, which are basically, if the rotation of the drum in the opposite direction to the revolution is effective in fine grinding of the material, mechanochemically activation of the material, and also mechanical alloying due to larger impact energy of the balls during the milling process. Okay, so please note that rotation of the drum opposite to the revolution is effective way in order to get a very fine nanoparticle, and these nanoparticles will be more mechanically active, and they are well mechanically allied, because the impact of the energy of the balls will be higher on the bulk material due to the opposite rotation of this drum with respect to the revolutions. Okay, so they will cause a creation or production of very fine nanoparticles. Another key parameter to consider in a ball milling apparatus is milling time. The student, usually if the milling time is higher, there is a possibility of getting fine nanoparticles. But the student, this milling time has a pros and cons. It has advantages and disadvantages. Higher milling time will also cause an increase in a wear and also an increase in a friction, which may result into a production of an impurity in desired nanoparticles. Okay. Secondly, if the number of balls are too much, okay, and you increase the milling time, the ball will overlap for longer time and they will also cause an increase in impurity in the final product. Okay. However, if the ball are less, then increase in a milling time will be better in order to get a pure fine nanoparticles or nanomaterials. Just at advanced level, you have to consider the magnetic field in ball milling operators. But the magnetic field is used at advanced level. Please note that magnetic field is very important in order to separate the material which are magnetically active, okay, and they may flick and they may be like separated from the impurities during the ball milling process. As you know that if we consider Lorentz equation, Lorentz says that F is equal to QE plus QVB. Lorentz force is equal to electric force between the charges and the magnetic force. So magnetic field usually spiralate the magnetically active materials, whereas the electric current usually move the electrically active materials along a straight direction, straight ahead. So when magnetic field is applied in a ball milling apparatus, there will be a generation of electromagnetic waves or electromagnetic field, and with this electromagnetic field, the magnetically and electrically active material will be separated from the impurities present in the ball mills. But dear student, this setup is used at advanced level. Usually in industries, conventional ball mill apparatuses are used. Let us discuss about the types of the ball milling apparatuses. Okay, so dear student, please note that ball milling apparatuses are different types. They are usually maybe based on the shape of the ball drum. They usually use a cylindrical ball mills like horizontal and vertical ball mills. The ball mill operators may also the type of the ball mill may also depend on the grinding medium, that what kind of medium should be used in ball milling should be used for the ball mill, like what kind of for what medium ball mill apparatus will be used. So ball mill apparatus may be based on discharging methods. It's maybe based on continuous or pulse or frequent grinding. Okay, it's maybe based on transmission methods. Okay, and the ball mill apparatus may be based on grinding conditions. So the student, overall, the types of ball mill operators will depend on the grinding medium, the flow inside the ball milling apparatus, the shape of the ball milling apparatus, and etc. So on the basis of the desired requirement, there are different types of ball milling apparatus. The first, so dear student, the first type of the ball milling machine is based on its shape. Usually these ball mill apparatuses or machines are cylindrical in shapes. Okay, so like this, they are cylindrical in shapes. Different types of cylinder are used in ball mill apparatus. The first type of cylindrical ball mill apparatus machine is usually a short cylindrical ball mill apparatus. Dear student, please note that the length of the short cylindrical ball mill apparatus is less than twice the diameter of the cylinder. Okay, it is less than the diameter of the twice of the diameter of the cylinder. So just please note that the length of the cylinder in a short cylinder ball mill apparatus is less than twice of the diameter of the cylinder. This means that the ball mill with length is equal to 2d, or diameter may be, if the 2 or the diameter 2d may be larger than the length of the cylinder. Okay, so dear student, in a simple word, the length of the diameter of the short cylindrical ball mill is less than the twice of the diameter of the ball mill apparatus. Okay, so this type of ball mill apparatus is known as short cylindrical ball mill apparatus. Another type of the ball mill apparatus is known as medium long ball mill apparatus. Okay, so the medium long ball mill apparatus have a length slightly more than the 2d of the ball mill. So usually, dear student, the length of the ball mill apparatus or ball mill drum is around or is equal to the 3d, or is equal to the 3 times of the diameter of the cylinder of the ball mill apparatus. Okay, so in a simple word, a medium long ball mill apparatus have a length higher than or equal to the 3 times of the diameter of the ball mill drum. Okay, so the third type of the cylindrical ball mill apparatus is known as long cylindrical ball mill apparatus. So the long mill cylindrical apparatus have a length around 4d, or 4 times of the diameter of the ball mill drum. Okay, so the length is too much in long cylindrical ball mill than the diameter of the cylinder. So in a conclusion, dear student, please note that a short ball mill apparatus have a length equal or lesser than the 2 times of the diameter of the ball mill apparatus, whereas the medium cylindrical ball mill apparatus have a length equal to the 3 times of the diameter of this ball mill drum, whereas in long cylindrical ball mill the length is of more and than 4 times of the diameter of the ball mill drum. So on the basis of the length and diameter of the drum of the ball mill, the type of the cylindrical type of ball mill apparatuses are classified. Okay, another type of the ball mill apparatuses are based on grinding medium. The student, the grinding medium mean a material which are the balls which are used to grind a bulk material. So these types of ball milling apparatuses are based on the nature or the material which are used as a ball. Okay, the most commonly used ball in grinding medium ball mill apparatuses or short steel ball mill apparatuses. Okay, so the short steel ball mill apparatuses have high grinding force and stable speed, so they are very commonly this type of ball milling machine is used in very fine grinding because they use very high force and stable speed. Another type of grinding or ball milling machine based on a grinding medium is rod mill ball milling machine. Basically, a rod mill ball milling machine is based on or are usually equipped with steel rods with diameter mostly between 50 to 10 millimeters. And the drawback of the rod mill machines are is that they need a longer time to grind the bulk material. The number of the bin in the rod mills are usually between 2 to 4, and there are some differences in grinding media loaded in each bin. To ensure the final effect of the grinding, the staff will place the cylindrical steel rod in the first bin and the steel ball or steel segment in the several other bins. Okay. In a simple word, the rod mill process use usually use steel rods and their diameter is around 50 to 100 millimeter. But the issue with the rod mill based ball mill apparatus is that they require longer time to grind the bulk or precursor or initial material. Okay, another type of the ball mill apparatus based on grinding medium is known as gravel mills. Okay, so this is a third type of the ball milling apparatus. So dear student, it is clear from the word gravel mill that the gravel mill uses the gravels. Okay, the grinding medium in the gravel mill mainly include the pebbles, gravels, sandstones, ceramics balls. Okay, so they are commonly used. Okay, the gravel mill mostly used in granites, and as well as they are also used in production of cement or cement industry. So basically mill this type of mill is very common in the granite and cement industry, and it's used the gravels which are as a medium which usually are used as a crushing material, which crush the material and convert them into a very fine particle. So this is the third type of the ball mill apparatus based on the grinding medium. Okay, the first type of the ball mill apparatus based on grinding medium is a steel ball mill. The second type of the ball mill apparatus is based on a rod mill, and third type of the ball mill apparatus based on a grinding medium is a gravel mill, which used gravel and pebble for crushing and converting converting a bulk material into a very fine material. And this type of mill is most common in granite and cement industry. Okay, so dear student, please note that the third type of ball milling apparatus is based on uploading of the precursor or bulk materials. Okay, on the basis of uploading a bulk material, ball mill apparatuses are divided into two types. First type of ball mill apparatus is known as tail discharge ball uploading ball mill apparatus. Okay, dear student, please note that in the tail discharge, the head end tail of the tail discharge mill are used as inlet and outlet of the materials. So in tail discharge, the head and the tail of the ball mill drum are used as an inlet and outlet for the bulk material. Okay, when the mill is working, the material is fed from the inlet. Okay, from the head the material is incorporated from the inlet in and discharged from the outlet or from the tail. So basically, in a simple word, dear student, tail discharge of ball mill uploading material ball mill is based on head and tail. Okay, the precursor material or the bulk material which we want to convert into a very fine nanoparticle is incorporated either from head or tail, depend whether they act as an inlet or outlet. So when they are incorporated, then when they are crushed, they are exited either from head or tail. So both the head or tail in tail discharge ball mill apparatus act as inlet and outlet of the bulk material. Another type of the ball mill apparatus based on uploading bulk material is known as middle discharge ball mill apparatus or ball mill machine. So dear student, please note that the inlet of the middle discharge mill is both at the ends and the outlet is in the middle of the mill. Okay, so the inlet is present at head and tail of the mill. However, the outlet is present at the middle of the ball mill apparatus. Okay, so dear student, in this machine the materials are fed from the both ends. Okay, and then they are discharged from the middle of the drum of the ball mill apparatus. Okay, so these are the two key type of ball mill apparatus based on the uploading material. So dear student, please note that the fourth type of ball mill machine is based on the discharging method of the precursor or bulk material. Based on discharging method, the ball mill machines are divided into three main types. First type of ball mill apparatus based on discharging method is known as overflow type ball mill apparatus. In overflow type ball mill apparatus, the ore or the final product is discharged through a hollow shaft. Okay, so it is discharged through a hollow shaft. So when the precursor material or the bulk material is crushed inside the chamber of the ball mill machine, they are discharged through a hollow shaft. The second type of discharge ball mill apparatus is known as a grid type ball mill discharge machine or apparatus. So in grid type ball mill apparatus, the final product is discharged through a grid plates. Okay, there are grid plate present in the ball mill apparatus. When the product is converted into an ore or into a final product or into a fine material, it is then discharged and it is then removed from the ball mill machine through a grid plate. Third type of the ball mill apparatus based on discharge method is known as peripheral type of ball mill apparatus. Okay, so the word, it is clear from the word peripheral that in this type of ball mill or machine or apparatus, the final product is discharged around the cylinder of the ball mill apparatus. Okay, so these are the three main types of ball mill machines which are based on discharge method, or which are based on the way through which the final product is discharged from the ball milling apparatus. So dear student, the fifth type of ball milling apparatus depend on the driving mode or driving power of the ball mill apparatus. Okay, on the basis of driving power, the ball mill apparatus or ball mill machine is divided into a central drive ball mill machine or edge drive ball mill machine. Okay, dear student, please note that a central in a central power central drive ball mill machine, the drive power device is in the center of the fuselage and the motor realizes the operation of the ball milling through the reducer in operation. The hollow shaft in the center of the ball mill drive the grinding body to rotate under the drive of the power system. Okay, so dear student, in a simple word, the power device in center drive ball mill apparatus is present at the center of the fused material. Okay, or the material which we want to convert from a bulk into a fine material. Okay, and okay, the operation of the ball mill is realized by a motor mm, through the reducer which is in operation. Okay, and the hollow shaft in the center of the ball mill drive the grinding body to rotate under the driving power of the system. Okay, so basically the center power source which is present at the fuselage or at the center of the bulk or material is controlling the conversion of the bulk material into a fine material. Okay, so the second type of, as I discussed, of the drive mod ball mill apparatus or machine is edge drive ball mill apparatus. In the edge ball mill drive apparatus, the motor drive the gear at the edge of the cylinder. Okay, so it's drive the gauge at the edge of the cylinder through the reducer, and that basically result into a conversion of a material, bulk material, into a ore and or a fine material. So basically, please note that this fifth type of ball mill apparatus, which is known as drive mode ball mill apparatus, depend on the condition or the place where we put the power source for the conversion of the bulk material into a soft or fine material. So if the power which device is placed at the center of the ball mill apparatus, that it is known as central drive ball milling, whereas if in the case if the power source is placed at the edges, then the such type of ball mill apparatus is known as edge drive ball mill apparatus. So the student, the sixth and very known type of ball mill apparatus which is commonly used is known as ball mill apparatus based on characteristic. Okay, so based on characteristic, ball mill apparatus is divided into two types. First type of ball mill apparatus is known as wet type ball mill apparatus, whereas the second type of ball mill apparatus is known as dry type ball mill apparatus. Okay, so dear student, it is quite easy to understand the ball mill machines based on characteristic, like wet type ball mill machines usually use a water as a waters during a feed in the and during a feed formation, and usually it's convert the bulk material into a slurry. Okay, so dear student, in wet type ball mill apparatus, a water is added at the same type of feeding and material is discharged into a certain concentration of a slurry. So in a simple word, in a wet type of ball mill machine, water or and even at advanced level different types of solvents are incorporated inside the crushing material of inside the drum of the ball mill apparatus during the crushing or feeding, and this water or a solvent convert the crushed material into a slurry having a different concentration. Okay, and then the slurry is further used and defined into a nanoparticle or nanomaterial, whereas in a case of dry mill type material, some dry type of ball mill apparatus, some discharge materials are extracted by airflow. Okay, so the airflow is used in dry type ball mill apparatus, so there is no a wetting medium used in dry type ball mill apparatus, and in a drying condition a bulk material is converted into a fine nanopowders or nanomaterial. Okay, so the student, the seventh type of ball mill machine is known as cylindrical type ball mill machine. Usually this ball mill machine is based on the shape of the ball mill drum, which is usually a cylindrical. Okay, so based on the shape, ball mill apparatus is divided into two types. One type of ball mill apparatus is known as horizontal type ball mill apparatus. Okay, and second type of ball mill apparatus is known as vertical type ball mill apparatus, like this. Okay, so the student, please note that the horizontal ball mill apparatus is used for grinding and dispersing under the closed conditions. Okay, so dear student, in a simple word, the horizontal ball mill apparatus grind and disperse the bulk material in the closed condition, and which basically prevent the volatilization of the solvent which is usually incorporated in ball mill machines. Okay, so it is very suitable kind of material, suitable kind or suitable type of ball mill machine if you want to prepare a very fine grinded material. Okay, and having a high purity. So in a simple word, students, horizontal type ball mill operators have a horizontal shape like this, and it is usually operated under the closed conditions, so the environment is not from outside is not interacting with the inside setup of the ball mill operators, and in this way the crushed material is very fine and very pure. Okay, whereas the second type of ball mill machine, which is based on shape, is known as vertical type cylindrical ball mill operators. Basically, this is a new type of ball mill machine which places the cylindrical structure upright. Okay, so this structure is placed cylindrically and it is cylindrically upright. Okay, this student, please note that through different types of experiment, it is found that the vertical ball mill has an advantage of high grinding efficiency and low energy consumption, and also no low noise. So this vertical ball mill operators has advantage over the horizontal ball mill operators. It is experimentally proven. Okay, so I'm not claiming, but it's experimentally proven by different scientists that the vertical ball mill operators is highly advantageous because of its efficiency of low power consumption, and also because of the low noise ratio. So noise inside the ball mill operators is very less, and the energy, which is usually in the form of electricity, so it usually consumes less energy as compared to the horizontal cylindrical ball mill operators. So as experimentally it is proven, this type of vertical ball mill apparatus is a key part of the materials industry because of its efficiency and because of its less noise as compared to the horizontal type ball mill apparatus or horizontal type ball mill machine. So the student, all the types of ball mill operators discussed are widely used for different purposes. Let us discuss that some of the common ball mill operatives which are more familiar, which are mostly used for nanomaterial synthesis. So few types of the ball mill machines used for nanomaterial synthesis are. So the student, first type of the milling machine used to convert a bulk material into a fine nanomaterial is known as drum ball mill machine. The student, please note that in drum ball mill machine, the sample, which is usually a pre-crushed material or which is usually a bulk material, is placed inside the drum, which have the grinding balls, and they are both the bulk material and the grinding ball inside the drum are subject to external force. Okay, so when the external force is applied on the drum start to rotate around the horizontal axis. So due to the horizontal axial rotation, the balls which are present inside the drum will interact with the bulk material. So the milling ball will crush the bulk material into a very fine nano powder or nanoparticles. Dear student, please note that drum ball mill is very good machine in order to get a very fine nanoparticles. Commonly, dear student, please note that the grinding balls used in drum ball mill operators are usually in size from 10 to 30 millimeters. So usually the balls used for grinding in drum ball mills are have a diameter of around 10 or 20 or 30 millimeters. So dear student, please note that this means that there are three different separation grids which can be used and which are also available. Okay, so in drum mill the sample which is pre-crushed is placed inside the drum with a grinding ball, and the grinding ball have a diameter of 10 millimeter, 20 millimeter or 30 millimeters, and this grinding ball crush and convert the bulk material into a very fine nanoparticles. So dear student, in a simple word, the material which is in the form of bulk is converted into a nanoparticle or a particle in a range of few hundred nanometer by crushing and impact. Usually, dear student, please note that around 80 kg of the bulk material is converted very easily at once using drum ball milling operators. Different another type of milling up machine used for preparation of a nanomaterial is known as jet mill machine. Okay, so in jet mill machines, so in a jet mill machine, the machine grind a material into a very fine nanoparticle by using high speed jet of a compressed or air or inert gas which impact the bulk material into a nanoparticles. Okay, so jet mill can be designed to output the particles below a certain size. So basically we can achieve and we can design a jet mill based on compressed air or inert gas to convert a bulk material into a fine nano powder. Another type of the common milling machine used for the conveyor of bulk material is known as bead or bed mill machine. Okay, the student, please note that the bed mill machine is very common in crushing a bulk material into a fine nano powder or into a fine powder. It is very common in the cement industry and also in the different types of micro and nano electronic industries. The bed mills usually grind and disperse the material or bulk material into or down to the size of micro or nanometer scales. Okay, so dear student, please note that in bed mills the beds or gravels are used as a grinding medium. They are also important part of the cement industry. Okay, so dear student, please note that bed mills are a grinding and dispersing machines. They are designed to grind and disperse the particles down to micro and nanometer scales. Beds inside the grinding chambers are agitated by rotating the shaft, and the particles are ground and dispersed by collision and shear force of the bed. Okay, so in bed mill, the beds basically which are act as a grinding medium, they cause the collision and shear with a bulk material, and in this way bulk material is converted into a fine material. Okay, this is another type of milling machine used for the fabrication of nanomaterial is known as vibrational ball mill machine. Okay, This vibrational ball mill machine is based on vibration. Just please note that this vibration ball mill machine is also known as vibrational crushing ball mill machine. So, dear student, please note that the ball mill work by using a ball to grind the material. So, material such as iron or pans and ceramics are added to the ball mill. Next, the ball mill is activated so it rotates either vertically or horizontally. As the ball mill rotates, the ball bounces around while striking the enclosed material. So now, when the ball milling machine is vibrated, this means that the balls inside the vibration ball milling machine will start vibrate and they will interact with the bulk material. So when the vibrated grinding mediums like a ball interact with the bulk material, they increase the rate of the crushing of the bulk material. So in this way, huge amount of the bulk material by vibration is converted into a fine nano powder. So student, another type of the ball mill machine is known as horizontal rotary ball mill machine. Basically, it is clear from the name that the horizontal rotary ball mill machine is basically a rotational ball mill machine, and this machine basically rotate horizontal along the horizontal axis. Okay, and in a simple word, the horizontal rotary ball mill machine rotate around the horizontal axis, and it is partially filled with the material to be grinded plus the grinded medium. Okay, so this horizontal rotatory ball mill machine is partially filled with a bulk material which we want to convert into a nanoparticle, and it is also partially filled with a balls, okay, which are used as a crushing material which crush the bulk material. Okay, so please note that the uh, nature of the ball used in horizontal rotary ball mills will depend on the nature of the material which we want to crush. Okay, please note that there are different types of crushing ball used, and some of the common ball used in horizontal ball mill are usually a rotary ball. Usually they are ceramic balls, they may be a flint pebbles, and they may be a stainless steel balls. Okay, so it's depend. So the ball used for crushing in the horizontal rotary ball mill apparatus depend on the nature of the bulk material which we want to convert into a nanoparticle. So based on the bulk material, most commonly used balls in rotary horizontal ball mill apparatus are pebbles or ceramics or either stainless steel balls. Another type of ball mill apparatus is known as vertical ball mill apparatus. I have also previously discussed this one. It has a better in terms of efficiency, and power usage of the vertical ball mill is less as compared to the horizontal ball mill apparatus. Rest, the setup of the vertical and horizontal is same. So usually it is designed vertically, whereas the horizontal ball mill apparatus is designed horizontally. Okay, the next type of ball mill apparatus is used for the preparation of a bulk material into a nanomaterial is known as planetary ball mill apparatus or planetary ball mill machine. The student planetary ball mill machine are smaller in size. They are mostly used in laboratories for grinding a sample, like grinding a sample which is in the form of powder and convert it into a nanoparticle. So it is used in a small scale. A planetary ball mill consists of at least one grinding jar. Okay, it consists of a grinding jar which is arranged eccentrically on a so-called sun wheel. Okay, so it has an eccentric, the planetary ball mill have an eccentric setup having a jar, and in that jar the crushing balls are incorporated, and they crush the crush the bulk material which is at a small scale into a nano powder or nanomaterial. Okay. Please note that this planetary ball mill is used at industrial scale, but it is it is applied to medium material, medium hard material. It is also useful in hard materials, brittle materials, and also fibrous materials. In a planetary ball mill machine, the balls which are present in a cup of this machine are usually moved along the planar direction, and with the planar movement they interact with the bulk material and they crush it into a fine powder. Okay, and another type. Now the student, what do you think how a bulk material is converted into a nanomaterial in ball milling? This must be a first question in your mind, that how the ball milling technique is used to convert a bulk material into a very fine small nano powder or nanoparticle or nano material. Dear student, please note that in ball milling, the material is grinded as a result of abrasion during a relative movement of ball and particles, and the impact of ball against the materials when they fall from some height. Okay, so in a simple word, ball milling process is simply a grinding process of a bulk material. The grinding is done due to an abrasion of the balls which are used in ball mill apparatus with a bulk material, and when the abrasion of the balls take place with the bulk material, the result of the impact of the ball with the bulk material result into a fine nanoparticles or nanomaterial. So in a simple word, student, in ball milling apparatus, initially a bulk material is incorporated and there are grinding balls inside the ball mill apparatus. So these grindings start due to external force, start abrasion with bulk material, and due to abrasion and impacts of a balls with a bulk material, they result into a conversion of the bulk material into a fine nano powder. Okay, so dear student, it is clear from the name ball milling that the ball milling method consists of a ball and the milling chamber. Okay, so this technique involves milling balls which convert a bulk material into a powder and a chamber in which these milling balls are present. The powder material is taken inside the milling chamber. Okay. Usually, bulk material in ball milling is in the form of powder, and the ball mill crush that powder, which is in the form of bulk, into a nanoparticle or into a very small particulates. Okay. Please note that, as I previously discussed, usually in milling apparatus, the ratio of the ball to the powder or the bulk material is between uh, 10 to 1 or 20 to 1. However, in general, at small laboratory scale in grinding ball milling apparatuses, the ratio of ball to powder is around 2 to 1. So please note that in simple ball milling apparatus, in small industry scale in labs, the ratio of ball to the powder is around 2 to 1. However, this ratio may vary between 20 to 1 or between 10 to 1 to 20 to 1, but it depends on the material which we want to crush in a ball milling apparatus, okay, or in a ball milling machine. Please note that this ball milling method is more commonly used in crushing and grinding of the nanotubes, and commonly used balls are based on ceramics, flints, pebbles or stainless steel balls, so they are used as a crushing material to crush a bulk material. Okay. Dear students, just for your information, in nanotechnology, high energy ball milling, which is also known as a mechanical deformation process, is more frequently used for producing a nanocrystalline metals or alloys in a powder form. So high energy ball milling method, it is a type of ball milling method. It is more commonly used in producing of nanocrystalline metals and alloys in a form of powder. This technique belongs to Etruscan approach. Okay, so it is based on an Etruscan, or in a simple word, this method is also known as mechanosynthesis or Etruscan process. Okay, so high energy mechanosynthesis or high energy Etruscan ball milling process is the name of this method, which is commonly used especially for preparation of the nanomaterials in nanotechnology. Okay, the ball milling is known as chemical synthesis method because this method usually do not involve chemical reaction. Okay, it just crush the nanoparticle in mechanically by impact. Okay, but in some cases there may be used a chemicals or a solvent in order to convert a bulk material into nanomaterials. So ball milling is one of the central technique of mechanochemical synthesis, that is a chemical synthesis by action of mechanical force such as by grinding, stretching or shearing. So basically ball milling just grind or shear or stretch the material mechanically, so it do not involve any kind of solvent during the process, and with the mechanical stress, shear or grinding, it's convert a bulk material into a smaller fine material. Apart from the preparation of nanotubes, there are also reported in different published papers that ball milling is also frequently used in preparation of nanoparticles. Some of the most common nanoparticles prepared by ball milling process are zinc oxide nanoparticles and titanium oxide nanoparticles. So ball milling, in a simple word, is a very diverse technique. It's may be used in preparation of, in crushing in conversion of nanotubes into small particulates, and it's also used in preparation of the nanoparticles. Okay, and also please note that this crushing or conversion of the bulk material through ball milling take a lot of time. Usually it may be like the process may continue up to 24 hours. So in a simple word, ball milling is a time consuming method. Like you can prepare a nanoparticle over the longer period of time. This method is not as good as like different types of nanoparticle synthesis techniques, but still it is a kind of a first step of top to down approach to synthesize the nanomaterial from bulk material. So it is a kind of a foundation step of the synthesis process based on top to down approach. And further, with the time this method is developed and new methods were introduced in order to produce very fine nanoparticle with high purity. Distant, based on our discussion, what do you think? What are the essential part of the ball milling machines? Like, what are the parts? What are the components used in ball milling machines? Distant, please note that ball milling machine consists of a rotating hollow mill or a drum. So this machine consists of a drum, and this drum is usually a hollow or empty. Okay, so this ball milling apparatus consists of a rotating or a hollow drum, and this rotating or hollow drum is consist or is partially filled with a grinding ball which are based on stainless steel, ceramics or rubber. So in a simple word, a ball milling instrument consists of a rotating hollow drum. This rotating hollow drum is partially filled with a grinding medium or grind the material or grinding balls. So grinding balls are usually steel, stainless steel, ceramics or rubber. Okay, please note that the student, the grinding ball inside the ball milling chamber or ball milling drum will depend on the nature of the material which we want to convert into a nanoparticle or nanopowder. So in case if you want to convert a soft material, usually the rubber balls are used for the crushing of those materials. However, in case of hard materials, steel, stainless steel, ceramics, like zirconium oxides or different types of ceramics are used to convert the hard material into a nanopowder. So the ball inside the ball milling drums are based on the material which you want to crush. Please note that the ratio of the ball present inside the hollow drum of the ball milling apparatus is 2 to ratio 1 of the initial precursor or initial bulk material. This ratio may vary and the ratio may reach up to 20 to 1, but it depends on the material which we want to crush. Okay, the ball milling apparatus, as the internal part of the ball milling apparatus is hollow, okay, it is empty. So the inner part of the hollow mill is lined with abrasion resisting materials such as manganese steel. Student, what do you think why the internal part of the ball mill uh, machine is coated with abrasion resistant material? Please note that this hollow part of the ball mill is made of any kind of material. Okay, so it is a certain type of an elemental material. Okay, so we have incorporated a bulk material inside this hollow chamber, and the ball are also present. So these ball will interact with our incorporated bulk material, and the interaction of the ball with the bulk material is at certain frequency and certain speed. So the balls are rotated usually around 10 to 40 rpms. Okay, so these balls have a rotation, and also the bulk material have a rotation. So these balls, or either the crushed bulk material, will interact with the external surface of the drum. So when they interact, they will result into an abrasion, and the external material, which is external, and the outer surface of this hollow drum, will interact with the balls and also with the powder. So they will result into impurity. The powder which is prepared will have an impure material from the surface of the drum. So due to this, we will never get a pure nanopowders. So in this case, the ball milling machine use an abrasion resistive materials. Okay, so they are friction free materials. So when the particles when the bulk material which we want to crush and the ball interact with the abrasion resistant material, they will never peel off from the surface of the drum, and they will never be incorporated onto the nano powder. So in this way we get highly pure material. Okay, so due to this, the abrasion resistant coating is very important in ball milling apparatus. Okay, and just simply note that usually in industrial scale, the diameter of the ball used in ball mill apparatus is small. However, if the diameter is more, usually the diameter of balls used are in the range of 10 millimeter to 20 millimeter. However, in some cases the ball diameter increase up to 150 millimeter. So their weight is also too much, so the impact of the ball will be higher onto the external coated surface of the drum, so they will increase more impurity. So in order to avoid the impurity, the abrasion resistive coating is done in ball milling drum. Okay, so these are the three essential components of the ball milling apparatus. The first is the drum of ball milling apparatus. The second one is the ball present in the ball milling apparatus, okay, and the nature of the balls. And third one is the abrasion resistive coating of the ball milling drum from inside. So dear student, let us discuss the processing steps involved in ball milling method, like how we can prepare nanomaterial or fine nano powder. What are the processing steps required in order to prepare a fine nano powder using a ball milling method? In first step, dear student, the precursor material or the bulk material in the form of a powder is incorporated in ball milling drum. As I have discussed in previous slides, that ball milling apparatus consist of a ball milling drum. Okay, so the bulk material is incorporated in the ball milling drum in first step. So now when the bulk material is incorporated inside the ball milling drum, please note that the ratio of the ball to the bulk material is very important, especially in case of preparing a nano material. Okay, as I previously discussed, the ratio may vary from 2 to 1 up to 20 to 1. However, in order to prepare a nanomaterial, the ratio of the balls to the bulk is very important. So 2 to 1 ratio ball and bulk are incorporated in ball milling drum. So in processing step, in first step, the bulk powder is incorporated in ball milling drum. Okay. In second step, the ball are introduced in ball milling apparatus. Okay, and the ratio of the balls to the incorporated powder is in the range 2:1. Okay, so when the balls are introduced in a ratio 2:1 to the powder, then in next step the rotation of the ball mill will start. Okay, and when the ball mill rotate, the ball will have an impact on the powder material. So due to impact of the ball with a powder bulk material, they will result into a conversion of a bulk material into a fine nano powder. Okay, please note that the rotation of the drum of the ball milling apparatus is done externally. So externally the ball mill is rotated, and due to external rotation the balls inside the ball mill will impact the bulk material, and due to impact the bulk material will be converted into a fine nano powder. Okay, students, please note that the nature of balls used in ball mill apparatus will depend on the nature of the bulk material which we want to convert into a nanoparticle. Students, please note that at advanced level magnetic field is used in ball milling apparatuses. That magnetic field result in mechanical energy and breakage of the bulk material. So that is an advanced study. There is also study related to impact of the electromagnetic waves or electromagnetic force on to the element or onto the material which is converted into a fine nanoparticle. However, this discussion is above the scope of our current existing lecture. Okay, we will discuss the impact of magnetic field, that how the magnetic field result in cross-correlation and movement of the magnetically and electrically active element inside the ball milling apparatus, but they are not in the scope to this lecture today. Okay, so in a simple word, the processing step of ball milling process involve incorporation of a bulk material in a ball milling drum. The ball milling drum has a ball in it which are used for the crushing of the bulk material. The ratio of the balls to the ratio of the crushing powder material is 2:1. Okay, and when the ball milling apparatus is rotated externally, the ball inside the ball mill apparatus will cause an impact on the powder, and due to an impact the powder will be converted into a fine nanoparticles. Okay, so these are the three main processing steps involved in ball milling process for the synthesis of nanoparticles or nanomaterials. Please note that, dear student, as I previously discussed, the ball milling process usually takes 24 hours. But in order, if you want to prepare very fine nanoparticle, the time of ball milling rotation may take up to hundreds and even 200 hours. So this process is time consuming process. So in a summary, the ball milling process involves incorporation of bulk material in a ball milling drum which has a ball in it, and when the ratio of the balls to the incorporated bulk material is 2 to ratio 1, when the ball milling drum is rotated, the ball will result into an impact onto a bulk material, and due to impact the bulk material is converted into a fine nano powders. So these are the main 3 processing steps involved in ball milling process. So let's then discuss that what are the advantages of ball milling process. What do you think? Is there any advantage of ball milling process? Yes, of course there is. The ball milling method is very simple because the nanomaterials are very difficult to prepare, and there are very complex methods like solution-based methods like sol-gel process, microemulsion process, milli-emulsion process, co-precipitation processes, or high vacuum based processes like pulse laser deposition, like chemical vapor deposition, or physical vapor deposition like electron beam evaporation. All those techniques are very complex and they are very precise, but they need they are costly. So of course ball milling process is a very advantageous process. It has advantages. Let's discuss few of the advantages of ball milling process. Student, ball milling process is simple and effective. Why this process is simple? Just this is a crushing technique. It doesn't involve any kind of chemical reaction. It doesn't involve any kind of solvent in it. So just you go incorporate the precursor material or bulk material in the ball milling machine, just rotate it. The infraction of the balls with the bulk material will result into a conversion of a bulk into a powder. So this is simple and effective technique. Another advantage of ball milling apparatus is that you can prepare very fine nanomaterials or fine nanoparticles with ball milling process. Even you can prepare a nanoparticle in the range of 2 to 20 nanometer. So this is something outstanding. No, it is very difficult for the methods like wet chemical solution based methods to prepare a nanoparticle in this range. So this is an advantage of ball milling process, that you can basically prepare a nanoparticles or nanomaterial in the range of 2 to 20 nanometer in size or in diameter. Another advantage of ball milling process is that the ball milling process is reproducible process and it is a large scale process. Dear student, please note that the issue with advanced technique is that you need to prepare a reproducible material or reproducible nanoparticle with a high purity. You cannot use a nanoparticle or nanomaterial which are not reproducible by the synthesis methods. And you also need to prepare a nanoparticle or nanomaterial at larger scale if you want to commercialize the nanomaterial into industrial setup. You need to produce a material repeatedly and you need to produce a material at larger scale. So this type of advantage is provided by a ball milling process, that the ball milling is a reproducible process because it don't involve chemical reaction. Every time you go and process the material, you will get the same result. This is something very good. And secondly, you can prepare a fine nanoparticle at very large scales, even in kgs. So it's too much. So you can produce a lot of material at the same time, and that material is reproducible. This is a very important advantage of ball milling process, in especially for industries. Okay. Another advantage of ball milling operators, ball milling method, is that the ball milling method is inexpensive and easy process. So you don't need expensive chemicals in ball milling process. You just need a bulk material which you want to convert into a nanopowder. Okay. Once you got the bulk material, then you just need to convert it into a nanoparticle just by crushing it. So in a simple word, ball milling is inexpensive and very easy process. So now let's discuss, student, what are the possible disadvantages of the ball milling process. What do you think? What could be the disadvantage of ball milling process? Of course, there are a lot of disadvantages of ball process, and that is the reason we advanced synthesis techniques like wet chemical solution based techniques or high vacuum based techniques were introduced in order to prepare a nanomaterial. So some of the key disadvantages of ball milling processes are the first disadvantage of the ball milling process is that the overall shape of synthesized nanoparticle in ball milling process is irregular. This is a key drawback of ball milling process. You cannot get a nanoparticle of a same shape using a ball milling process. Okay, since I have previously discussed that in the ball milling, the impact of the ball is used to convert a bulk material into a nanopowder. An impact of ball is done in a circular path by rotation of the ball milling apparatus, and this impact may be at different point of the bulk material. So as a result, you at the end of the day you will get a nanopowder or nanoparticle of different shapes. So this is the key drawback. You cannot get a uniform nanoparticle using a ball milling process. Another disadvantage of the ball milling process is that the rate of impurities and defect may be introduced during the milling or via ball. This is very important. Even it is serious drawback of the ball milling process, that this process involves impurity. You cannot get pure material with ball milling process, and also the impact which is created by the ball on the bulk material also cause a stress and defect in the structure of the prepared nanoparticles. So what this means, students, if you have an impurity or defects in a material prepared by ball milling process, then this technique is not more common for microelectronic industry, because every time you prepare a material with ball milling process, you will get impurity and defect. What do you think why impurity is introduced in ball milling apparatus? Different ball milling prepared powder. Different the impurity are usually created from the wall of the ball milling chamber. Number one. Number two, the impurity may be incorporated from the balls because we use the ball, they grind the powder. So ball have a certain elemental compositions. So these elemental composition will interact with the prepared nanopowders, and due to this you will never get pure material via ball milling process. And what do you think how the defects are created in ball milling process or ball milling powder? Since you know the balls are crushing the bulk material, so they are inducing, they are impacting a bulk material, and due to an impact there will be a disruption or destruction in the structure. So this is a serious drawback of the ball milling method, that you will never get a pure and defect free nanopowder via ball milling process. So dear student, thank you for watching our lecture series about the ball milling process for the synthesis of the nanomaterials. In new next lectures, I will discuss about the wet chemical solution processes for the synthesis of the nanoparticles. So in previous lectures, I have discussed the solvent process for the nano particle or nanomaterial or thin film synthesis. So in next lecture, I will briefly explain about the chemical co-precipitation method for the synthesis of nanoparticles and fabrication of thin films. So thank you for watching our lecture series about the ball milling process for the synthesis of nanomaterials.